Welcome. Today we are looking at simple AC circuits. This is topic 8 in your SS2 physics series. This topic is common in essay questions in your examinations. Pay close attention. Let us begin. First, let me explain what an AC circuit is. An AC circuit is a circuit that uses alternating current. Alternating current changes direction periodically. It is used for power transmission. It is used in homes and industries. AC circuits are different from DC circuits. In DC circuits, current flows in one direction. In AC circuits, current changes direction. AC circuits have additional properties. These include reactance and impedance. Understanding AC circuits is essential for understanding electrical power systems. It is essential for understanding electronics. Now, let me explain alternating current. Alternating current is current that changes direction periodically. It is produced by AC generators. The current flows first in one direction. Then it flows in the opposite direction. This repeats continuously. The frequency is the number of cycles per second. In Nigeria, the frequency is 50 Hz. The voltage also alternates. The voltage goes from positive to negative. The waveform is sinusoidal. It is a smooth wave. Understanding alternating current is essential for understanding AC circuits. Now, let me explain the waveform of AC. The waveform of AC is sinusoidal. It can be represented by a sine wave. The equation for the voltage is V equals V peak sine omega t. V peak is the peak voltage. Omega is the angular frequency. T is time. The current is given by I equals E peak sine omega t. The waveform repeats every cycle. The period is the time for one cycle. The frequency is the inverse of the period. Understanding the waveform is essential for understanding AC circuits. Now, let me explain resistance in AC circuits. Resistance is the same in AC and DC circuits. The formula is V equals IR. This is Ohm's law. Resistance opposes current. It causes energy loss as heat. The voltage and current are in phase. This means they reach their maximum at the same time. The power is given by P equals VI. Understanding resistance in AC circuits is essential for understanding circuit behavior. Now let me explain inductance in AC circuits. Inductance is the property of a coil. It opposes changes in current. It is measured in henries. In AC circuits, inductance causes the current to lag behind the voltage. The current lags by 90 degrees. The inductive reactance is given by XL equals 2 pi FL. XL is inductive reactance. F is frequency. L is inductance. Inductive reactance increases with frequency. Inductors oppose high-frequency currents. Understanding inductance is essential for understanding AC circuits. Now let me explain capacitance in AC circuits. Capacitance is the property of a capacitor. It stores charge. It is measured in farads. In AC circuits, capacitance causes the current to lead the voltage. The current leads by 90 degrees. The capacitive reactance is given by XC equals 1 over 2 pi FC. XC is capacitive reactance. F is frequency. C is capacitance. Capacitive reactance decreases with frequency. Capacitors oppose low-frequency currents. Understanding capacitance is essential for understanding AC circuits. Now, let me explain impedance. Impedance is the total opposition to current in an AC circuit. It includes resistance and reactance. The formula for impedance is Z equals square root of R squared plus XL minus XC squared. Z is impedance. R is resistance. XL is inductive reactance. XC is capacitive reactance. Impedance is measured in ohms. It is the AC equivalent of resistance. Understanding impedance is essential for solving AC circuit problems. Now let me explain series and parallel AC circuits. AC circuits can be series or parallel. In a series AC circuit, the current is the same through all components. The voltage is divided among components. The impedance is the total opposition. In a parallel AC circuit, the voltage is the same across all components. The current is divided among components. The total impedance is less than the individual impedances. Understanding series and parallel AC circuits is essential for circuit analysis. Now let me explain resonance in AC circuits. Resonance occurs when inductive reactance equals capacitive reactance. At resonance, XL equals XC. The impedance is minimum. The current is maximum. Resonance occurs at the resonant frequency. The resonant frequency is given by F equals 1 over 2 pi square root of LC. F is resonant frequency. L is inductance. C is capacitance. Resonance is used in tuning circuits. It is used in radios and televisions. Understanding resonance is essential for understanding tuning. Now let me explain the power in AC circuits. Power in AC circuits is more complex than in DC circuits. The instantaneous power varies. The average power is important. The formula for average power is P equals Ohms cosine phi. WMS is the RMS voltage. Ohms is the RMS current. Phi is the phase angle. The cosine of the phase angle is the power factor. The power factor is a measure of efficiency. A power factor of 1 is maximum efficiency. Understanding power in AC circuits is essential for understanding energy consumption. Now, let me explain the power factor. The power factor is the cosine of the phase angle. It is the ratio of real power to apparent power. Real power is the power actually used. Apparent power is the product of voltage and current. The formula for power factor is PF equals cos phi. A low power factor means more current is needed. This causes more losses. Power factor correction is used to improve efficiency. Capacitors are used for power factor correction. Understanding the power factor is essential for understanding efficiency. Now let me explain the applications of AC circuits. AC circuits have many applications. In homes, AC circuits provide power for lighting and appliances. In industry, AC circuits power machines and equipment. In communication, AC circuits transmit signals. In electronics, AC circuits are used in filters and oscillators. In power transmission, AC circuits are used for efficiency. Understanding the applications of AC circuits is essential for understanding technology. Now let me explain the importance of AC circuits. AC circuits are important for several reasons. First, they allow efficient power transmission. AC voltage can be easily changed using transformers. Second, they allow the use of alternating current. Most electrical devices use AC. Third, they allow the use of inductors and capacitors. These components are essential for many applications. Fourth, they allow resonance. Resonance is used in tuning. Fifth, they allow power factor correction. This improves efficiency. Understanding AC circuits is essential for physics and technology. Now let me give you sample exam questions. Define AC circuit. An AC circuit is a circuit that uses alternating current. State the formula for inductive reactance. XL equals dose PFL. State the formula for capacitive reactance. XC equals 1 over 2 pf se. State the formula for impedance. Z equals square root of R squared plus XL minus XC squared. Explain resonance in A. C. Circuits. Resonance occurs when XL equals XC. The current is maximum. State the formula for power factor. PF equals cos phi. Explain the importance of A. C circuits. A. C circuits allow efficient power transmission and use of transformers. Let me summarize. An AC circuit uses alternating current. Resistance is the same as in D. C. Inductance causes current to lag. Capacitance causes current to lead. Impedance is the total opposition. Resonance occurs when XL equals XC. Power in AC circuits depends on the power factor. AC circuits have many applications. Understanding AC circuits is essential for physics and technology. Practice these concepts. When you have them down, move to topic 9.